Welcome to this video. My name is Natalia Romero Herrera, and in this module we will discuss the topic of designing justice for energy transitions. We start with this video by explaining how justice is at stake when applied as an external principle to the technical optimization of energy systems. We'll examine how living labs are a suitable arena for justice to be intentionally designed through co-creation, experimentation, and continuous learning. By the end of this video, you will understand how bottom-up participatory design methods can support the co-construction of knowledge, of innovation, and of governance structures that enable more just energy transitions. Let's imagine the following scenario: a Dutch neighborhood with three key actors: a large football stadium with a 5-megawatt rooftop solar system, 350 social housing apartments, each with small rooftop PV panels, and the local distribution system operator, managing the grid stability. On sunny afternoons, the grid becomes congested. This means that the stadium produces large surpluses compared to the residents. Yet, the DSO curtails the social housing PV systems, first keeping full feed-in rights to the stadium due to contractual priority. From a technical perspective, the system is fair. Voltage stays within limits, blackouts are avoided, and efficiency is maintained. But from the residents' perspective, injustice emerges. First, due to curtailment, there is an unfair distribution of benefits as residents lose a percentage of their annual PV production, which means that their expected annual savings drop significantly. Secondly, DSO's decisions are based on technical modeling only, where residents are not consulted, and lack of negotiation capacity. Thirdly, this results in residents' specific vulnerabilities such as energy poverty and limited flexibility due to their working or living conditions not being recognized in the DSO's decision. And finally, this injustice has been happening for years without compensation. The grid is stable, but justice is not. If energy justice cannot be achieved by technical optimization, then we need new arenas for multi-stakeholders to co-create solutions. In this video, we will focus on living labs as a promising approach to design justice in energy systems. A living lab is a real-world environment where residents, engineers, policymakers, housing corporations, and grid operators work together in the actual context of the neighborhood to integrate several perspectives of a problem. To support this collaborative process, living labs enable justice through three levels of co-creation. First, it enables co-creation of knowledge by developing insights of the neighborhood from the bottom up. In our scenario, this could translate to mapping who's curtailed and what are the hidden vulnerabilities. Second, it enables co-creation of innovations by designing inclusive solutions that aim to redistribute decision power. In our scenario, this could result in alternatives to curtailment agreements or compensation mechanisms. Third, it enables sustained action and learning by building long-term learning communities that can adapt to the system over time. Let's unpack these three levels. The first level of co-creation in a living lab is knowledge, but not knowledge in the traditional expert sense, where the goal is optimizing what is measurable. To design for justice, we need to first understand how energy systems are experienced in everyday life. Who feels constrained? Who feels excluded? Who carries invisible risks? This type of knowledge does not emerge from grid models and from what is observable and measurable, what we indicate as a top of the iceberg. It emerges from lived experience, in our metaphor, what's underneath the top of the iceberg. Design methods can help surface this knowledge. For example, we can explore values and conflicts through structured dialogues. We can support residents to document how energy affects their daily routines through cultural props. And we can support stakeholders to visualize relationships between tariffs, contracts, vulnerabilities, and practices through context mapping. The main goal of these methods is to transform individual experiences into shared representations. A shared representation often results in a co-created narrative of the neighborhood, a story that allows engineers, residents, housing corporations, and DSOs to discuss the same system from different perspectives without reducing one to the other. Connected back to justice, through these narratives, we start building recognition justice by recognizing knowledge, and we start building on procedural justice by co-producing it. Once we share a new understanding of the system, we can begin to redesign it together. That brings us to the second level, innovation co-creation. We have seen that energy systems are complex. For example, when we introduce a new tariff, we change not only flows of electricity, but flows of power. In these complex systems, justice cannot be guaranteed in advance. Instead, it must be tested in practice. In a living lab, stakeholders use prototyping to experiment alternative socio-technical arrangements. These may include technical prototypes, such as a shared battery storage, institutional prototypes, such as a new curtailment agreement, or relational prototypes, such as a participatory tariff design workshops. These are tested at small scale. Understanding that unintended justice consequences are often invisible, design methods support stakeholders to collaboratively reflect on who benefits, who carries the risk. Based on this feedback, solutions are adjusted. In this way, experimentation and iteration allows justice to be corrected. But how do we learn from all these iterative processes of trial and error? This brings us to the third level of co-creation, sustained action and learning. As we argue, experimentation alone does not guarantee justice. Energy systems are dynamic and evolve over time. Tariffs change, new technologies are introduced, vulnerabilities shift. Justice must therefore be continuously monitored and negotiated. First, design contributes by structuring feedback loops as accessible and effective channels between stakeholders to legitimize understandings between technical, as in our scenario, and lived experiences. Second, through reflexive monitoring, stakeholders regularly assess whether the system remains fair. The reflection is not around did it work, but for whom did it work? Who was excluded? What unintended effects emerged? Thirdly, these processes, to succeed, require data practices that are also just and fair. For example, data about curtailment must be understandable to residents, available and accessible without barriers, open for contestation and for adaptation. In this way, justice becomes embedded in the ongoing operation of the system, not as a fixed outcome, but as a continuous learning process, addressing all tenets. Restorative justice with the ability to correct over time through experimentation. Procedural justice through continuous participation in co-designing experiments. Recognition justice by adaptive awareness of vulnerabilities to measure the impact on vulnerable groups. And distributive justice through recalibration of burdens to test who benefits and who pays. Now, in this video, we examine a scenario in which justice in energy systems cannot be achieved through technical optimization alone. We explore how living labs provide a space for bottom-up co-creation across 3 levels. First, knowledge co-creation, using design methods to surface lived experiences and transform them into shared system understanding. Second, innovation co-creation, prototyping alternative socio-technical arrangements and iteratively testing their justice implications. And third, sustained action and learning, embedding feedback loops, reflexive monitoring, and participatory governance into the ongoing operation of the system.